Hello everyone, myself Darshan Patil, and today we are going to present the most important topic, which is security measures across file system and operating system. So let me introduce my team members and then we move on to the next point. First is Om Sinkar, Atharva Pate and Parimal Dode. So in today's digital world, everything we do from saving documents, photos and code to managing servers and databases depends on how securely our files are stored and accessed. Operating system play a vital role in protecting this data from unauthorized access, modification or loss. So in this presentation, I'll explain what file system security means, the different security measures used, real-time examples of how they work, and what they are crucial in protecting users and organizations. So let's move on to our first point. What is file system security? Let's begin by understanding what a file system actually is. A file system is the method or structure and operating system uses to store, retrieve and organize data on storage device like NTFS on Windows, ext4 on Linux or APFS on macOS. Now file system security means the collection of techniques and policies that secures only unauthorized access or programs can access or modify files. It's like putting a digital lock on your folders and drives. Only those who have the right key or permission can open them. Without proper file security, anyone could steal sensitive information, corrupt file intentional or accidentally, or spread malware that damages the system. In today's time, many videos get leaked due to such mislead and stealing sensitive information from the mobile. This is the security cause that no one can open your mobile because without that key. Let's move on to our next point, which is causes and need for file system security. Now you might wonder, why do we need all these security measures? What causes security issues? Here are the main causes. Unauthorized access. Hackers or even unintentional users might try to access data they should not. Malware or viruses. Malicious software can infect files, encrypt them, or steal data. Data corruption. Hardware failures or software bugs can corrupt information files. Human error. Sometimes user delete or modify files by mistake. Network attacks. File shares over network can be interrupted or altered. Imagine, let's take an example. In 2017, the WannaCry ransomware attack encrypted millions of the files across Windows system worldwide, locking hospitals, businesses, and governments out of their data. This happened because their level security patches were not updated, showing how vital file system protection really is. Let's move on to our next slide, which is security measure in file system. Now let's move on to the core part, security measures across file system. Operating system use a combination of techniques to secure files. The most important ones are authentication and authorization. Before a user can access a file, they must prove their identity, usually through a username and password, biometric or security token. Once authorization, the OS checks what action they are authorized to perform, read, write or execute. Example, in Linux, a permission like read, write and execute use dash R for read, W for write and X for execute. You can assign this to the owner, group and other using command like chmod. Chmod is giving permission to the user. Then next is access control list, which is ACLs. ACLs provide final grained control over file access instead of only defining permission for user, group, other, and ACL let you assign customer permission to specify user and IDs. Let's take example. In Windows NTFS, you can set ACL so that a user can only read a file but not modify or delete it. Then next is file encryption. Encryption converts data into an unreadable format so that even if someone gets the file, they can't understand it without decryption key. Example, Windows uses EFS encryption file system. Linux supports eCrypts or LQKS encryption. Mac OS uses file vault to encrypt the entire data. Then next move on to our final point, which is real world example file security in an organization. Let's take a real world example. A company means there's a scenario, a company stores confidential employee data on its server. To secure it, it uses NTFS files permission to restrict access to HR staff only. The files are encrypted using EFS, so even if a hacker steals them, they are useless. Regularly backups are scheduled to take the security checks. Regular back then audit logs track every access attempts. Then let's move on to conclusion. File system security is one of the most crucial components of operating system. It ensures that our personal files, business data, and system file remain safe and unauthorized, except corrupt or lost. In short, security across the file system is the foundation of trust in computing. Thank you from my side. I'll give now permission to Om Sinkar to begin.
Hello everyone, my name is Om Sinkar and today I will be talking about how operating systems keep our files safe. I will explain two key parts. First, the main security measures that protect data, and second, how file security actually works inside the operating system. So, key security measures. As we know, every modern security system includes several layers of protection to secure user data. Here are some of the most important measures. First, access control. This defines who can read, write, or execute a file. It's implemented through ACS, that is Access Control List, that lists the specific permissions for each user or group. File permissions, which includes read, write, execute. These are the basic Unix or Linux permission model. The owner has full control over the file. Group members might have limited access, and others usually only have read rights. This simple model prevents accidental or unauthorized modification of system files. The third point is encryption. Encryption is conversion of readable data into ciphertext. So even if someone gets hold of the file, they can understand it without the correct decryption key. It's one of the strongest way to protect confidential data at rest and in transit. Fourth point is authentication. Before any access, the operating system verifies the user's identity through passwords, keys, or biometrics. Only verified users can enter the system. Fifth point is backup and recovery. Regular backups ensure that even if data is lost, deleted, or corrupted, it can be restored quickly. This keeps availability high. Sixth point is audit trials or logging. The system records who did what and when. These logs help administrators investigate security incidents or misuse. Seventh point is integrity checking. Uses hashes algorithms such as MD5 or SSA to detect any unwanted changes to files. If a file's hash changes, it may have been tampered with. Sandboxing runs programs in isolated environments, so even if a process is compromised, it can't harm the rest of the system. Altogether, these measures protect confidentiality, integrity, and availability, which are the core principles of security. Moving on to the next slide, how file security works in the operating system internals. Now let's look a bit deeper into how these protections actually work inside the operating system. File permission bits. For example, the permissions string rwxr dash xr means owner can read, write, and execute. The group can read and execute, and others can only read. These bits are stored in each file's metadata, its inode or directory entry, and are checked by the kernel every time a file is accessed. Access control matrix. The operating system maintains an internal table that defines which users or processes can perform which operations like read, write, or execute or delete on each file or directory. This ensures that even system level processes follow defined security rules. Secure attributes. Linux provides commands such as chattr plus I file.txt. File.txt is a file which makes a file immutable, meaning it cannot be deleted or modified until the attribute is removed. This is especially useful for protecting critical configuration files. Encryption process. The operating system can use symmetric algorithms like AES or asymmetric ones like RSA to secure file contents. Even if someone steals the storage device, they can still read the data without the encryption keys. Journalizing file systems, NTFS ext4. These maintain transaction logs of all file changes. If the system crashes, the journal allows quick recovery and preserves data consistency, which is a key part of file integrity. So, in summary, inside the operating system, there is a continuous coordination between permissions, encryption, and journaling mechanism, all working together to keep our files secure. So to conclude, operating system level file security is not just about passwords or permissions. It's a layered approach that combines access control, encryption, auditing, recovery to ensure our data remains safe, accurate, and available. Thank you. Now I ask Atharva Pate to proceed further.
This slide shows the real-world examples of the file system security across different platforms. I will explain each example, what it is, its main security features, how it works, and one real-life example. First one is a Windows. NTFS is a main file system used in the Windows computers. It controls the file access using the something called ACLs, means access control list. This list decides who can open, edit, or delete a file. NTFS also has a feature called encrypting file system, which encrypt the files for extra safety. Only the same user or an admin can open those encrypted files. For example, in a company, the finance folder can be locked, so only the finance staff can access it. Next one is a Linux. ext4 is the most commonly used file system in Linux. It gives the each file read, write, and execute permission, so also called RWX bits. Before any action, the system checks this permission for safety. SE Linux adds an extra security layer to stop unauthorized access. For example, on a web server, you can block access so it cannot read private system files. Next one is a Mac OS. APFS is a Apple's latest file system used in Mac OS and iPhones. It includes the built-in encryption to keep a data safe. Users can enable file vault to encrypt the entire disk. Only people with the correct password can access the encrypted files. APFS also supports the snapshots that let you recover the deleted data. For example, if you deleted the files by mistake, you can restore them using a snapshot. Next one is a cloud storage. For example, Google Drive and OneDrive. In cloud storage, allows users to store the files online securely. It uses the token-based logins to verify the right user. You can set permissions like view, commit, or edit. Files are encrypted both during upload and while stored. Cloud providers also keep the multiple secure copies. For example, in OneDrive, a file can be shared as a view only, so others cannot edit it. Now let's move to the role of organization. In role of organization, the first point is the security policies. In security policies, the organization makes security policies to protect their data. These are written rules about who can see or use information. They explain the password rules, backups, and what to do if data is lost. Following them helps prevent mistakes and data leaks. For example, only the HR team can access the employee details. Next one is the IT administrators. IT administrators are responsible for data safely in organization. They set user permissions, manage encryption, keys, and schedule the backups. They make sure only the right people can access files. They also help restore data if something goes wrong. For example, an admin gives the edit access only to the marketing team. This is the example for an IT administrator. Next one point is security audits. In security audits, check if the system follows all safety rules. They help find weak points or unauthorized access. Auditors review logs, permissions, and system settings. They report issues and suggest the security improvements. For example, an audit may find an old user account still active. Next one is a employee training. In employee training, the employees gets a regular training about the safe data handling. They learn how to spot phishing emails and fake links. Training teaches them how to use passwords safely. Next one is the sessions are done regularly to refresh their skills. For example, in employee training, the after training, the fewer people click on scam links. Then another is a security framework. Companies follow the global frameworks like ISO, GDPR, and HIPAA. These are the official rules to protect data and privacy. They help maintain the legal compliance and customer trust. organization gets certified by meeting framework standards. For example, GDPR gives the European users control over their personal data. Next one is the Parimal.
Emerging trends in cybersecurity. So today, cybersecurity is evolving to provide stronger protection for file systems and data. One major trend is zero trust architecture, which means no user or device is trusted automatically. Every access request might be verified. Another growing trend is the use of AI machine learning to detect unusual file activity and stop threats before they cause damage. With the rise of cloud platforms, the cloud security enhancement such as end-to-end encryption and multi-factor authentication helps keep each information safe. Blockchain technology is also useful for improving file integrity by preventing unauthorized tampering of logs and data. Additional data loss prevention system monitor and restrict sensitive information from leaving an organization, helping prevent leaks. Together, these trends make file security stronger and more reliable. Next slide. In conclusion, file system security plays a crucial role in keeping data confidential, accurate, and available. Modern operating systems like Windows, Linux, and Mac OS come with built-in security features, but best protection is achieved when we combine tools such as access control and regular security audits. Continuous monitoring and timing updates are necessary to defend against new and evolving cyber threats. And systems security helps organizations reduce risks, prevent unauthorized access, and ensure that important data stays safe and accessible. Thank you.